Let's move to the next speaker, who joined us from Spain and represents the Center for Genomic Regulation in Barcelona. Strong representation also here in Brno. Let's see the video first. Video of the Institute, please.
The genome is the blueprint of life. It contains all the information to make every living organism unique, and it defines health and disease. The journey to understand it has just started. There's still a lot to be unveiled about the secrets of life. At the CRG, we open new paths for genome research for a health revolution that cares for people, our planet, and biodiversity. We train our international young talent so they become the future pioneer minds of genome research through innovative and co-creating methods, giving them freedom to explore the unknown, finding new and more sustainable ways of doing science. We are constantly challenging the conventional knowledge of the genome, advancing new technologies and developing innovative applications. Ignited in Barcelona to improve people's well-being and the whole planet. Would you like to be part of our journey?
Barcelona. Well, you've heard of buses. Now you'll meet the Ferrari of the cell. In her high-energy presentation, Lida Katopodi will show how tRNAs aren't just delivery vehicles, but dynamic regulators of protein synthesis. And when they break down, things can go very wrong. Please give a very warm welcome to Lida Katopodi. And let's also connect with Barcelona, if possible, to say hello to the colleagues.
Hola!
You have an excellent support.
Fantastic.
You have an excellent support from Barcelona, also here in Brno. So I'm sure the presentation will be perfect. The floor is yours.
Thank you. Hello, everyone. As you probably guessed by my name, I am Greek. However, I am here representing Spain. I am representing CRG, and today we are going to embark on a journey. It's a different journey than the usual you've heard from Homer, my ancestor, who is very obsessed with heroes and gods, and probably wouldn't pay so much attention to us mere scientists. However, our journey today will be scientific, and we will learn how we will get a small whiff of the unbearable lightness of being. A tRNA. So, our story starts in the cell with this very, very small molecule. It's about 70 to 90 nucleotides long. And you probably know from high school biology that it grabs an amino acid from somewhere in the cell, brings it to the ribosome, and helps with the polypeptide synthesis. And that's it. Thank you. Exits that way, Esther? I have 3 more minutes for this talk, and I actually have more interesting things to say. tRNAs are way more exciting than we thought them to be. And this is because they have a ton of chemical modifications adorning their little bodies. This is a modification. It goes here, and it makes this tRNA faster, more efficient, and more beautiful. However, if you lose this modification, you get cancer. So it sort of makes sense that if you have such a potent clinical marker, you want to study it properly so that you can find it, you can study it as a potential therapeutic target or as a potential diagnostic biomarker. And this includes testing and studying both the modification context and the sequence itself. So far, there have been 2 ways with which we have been studying modifications, both of them with Illumina sequencing. One of them is antibody-based, the other is chemical treatment-based. You've probably heard about bisulfite sequencing. A bunch of people made a bunch of money out of it. But those are methods that target one specific modification. And as I mentioned, tRNAs are adorned by a multitude of modifications, and all of them are different to each other. So we need something stronger, something more potent. In comes Oxford Nanopore's direct RNA sequencing. For illegal purposes, I should say that this section of the presentation is not sponsored by Nanopore, however. If someone's watching and they have a job, please let me know. Thanks. PhD life is hard, guys. So what happens in direct RNA sequencing is that an RNA passes through the nanopore. It creates an electrical signal, which is then captured by the computer, and you get your sequence readout. In a modification-aware direct RNA sequencing, as a modified molecule passes through the nanopore, it creates a very distinct signal for the modification. So then, if we build this strategy, we will be able to not only capture the canonical base, but actually the modified base. We are very far from it, and this is a continued effort between wet lab and dry lab people. I am a bioinformatician, and people expect me to press my big red bioinformatics button and have this ready. However, reality looks a bit more like this. This is me on a daily basis. There's something missing. Still something missing? Yeah, that's me. However, I do love my science, I do love my tRNAs, and there's also one thing that keeps me going every day, and that is Elena Paparizou winning the Eurovision Song Contest 20 years and 1 day exactly ago. And to paraphrase her winning song, "You are the one, you're my number one, the only RNA I have in mind. You are the one, you're my number one. Anything for science, 'cause it's what I love."
Wow, this is incredible. These are such incredible presentations. Pavel, I'm looking at you again, but I mean, I was expecting a lot, but this will be like such a great presentation, so much fun, but at the same time very informative, and able to present their research in a very, very nice and understandable way. Really, I am amazed and very much looking forward to the upcoming presentations, of course.